Okay, as you've seen in other videos, I'm using these LED rings as displays of different parameters used to control the servo. And so it's showing the acceleration, the speed, and the distance. And it's a theoretical distance because we don't have any position feedback from the servo right now. This is just the commands being sent to the servo, what the servo is being instructed, how the servo is being instructed to move, how fast. But we actually do have all these extra wires. Can you see that in the video up here, just up in the top corner? All these are wires going to a magnetic encoder chip. And here's some of those, the circuit boards and chips that we have. So I have one of these small circuit boards inside the servo along with a magnet. Now unfortunately, I wasn't able to mount either the magnet or the little circuit board very precisely inside the servo. In fact, the circuit board is just stuck to some foam core board and is kind of wedged up inside the servo, and so it is not in a very precise position. And that shows when we actually go to get position feedback from the servo. And I'll switch modes here with the LEDs, so we're not using this mode anymore. We'll switch. Okay, this should be the position feedback one. Okay. Now here, the little blue dot is showing the encoder reading that we're getting back from the servo. And it should correspond pretty closely to this, where this red tape position is. And sometimes it does, sometimes it doesn't quite do that. Now we're still running the same ramped acceleration algorithm that I've been using in the other videos, recent videos I've made. And so we have a target speed, which is the speed the servo is being commanded to move. And as you can see, the encoder speed, which we're reading back from the magnetic encoder, doesn't always match the target speed. Now the target speed is always going to be, I think it's always a positive in the way it's being presented here. The encoder speed is going to be negative depending on which direction the servo is moving. So that's why in one direction the encoder speed will kind of match the target speed, but in the other direction it'll be opposite. And you can see how the encoder speed is very erratic and jumps around a lot. And I'm afraid that's due to the poor alignment of the magnet and encoder. And I'd be very interested to see, I haven't made any setup yet of a precisely positioned magnet over the encoder, but I'm hoping that it's possible to get this to be very precise. And even if we can't get this to be precise, I hope it's at least repeatable, and it appears to be. I noticed that the fluctuations in the speed output seem to correspond to the same position as it goes around. And so hopefully one could have the servo move in a constant speed, monitor that speed, and then create a table of adjustments for the speed at different positions. I'm not sure how, if it'd be great if you could very precisely manufacture a magnetic housing, something to hold the magnet over the encoder, where you get a very precise feedback on speed that would be consistent as it moves. I'm not sure if that's possible or not. And so then an alternative would be to come up with some sort of calibration table to correct for the speed at different positions. And I'll just let that go through a couple more times. And again, these are using these Austria Microsystem 5055 magnetic encoders. And the magnet inside is a 6mm magnet that's diametrically magnetized, that's made to use with these encoders. In case you haven't seen other videos, I have underneath here some neopixels from Adafruit. They're the neopixel rings. But they don't show up very well on the video camera unless I put some white paper in front. And even then they don't show up as well as they look a lot better in real life. And I think that's about it for this video. I do have one more video I intend to make.